Welcome back. In this video, I will go over the theory and practices of using a microplate reader for absorbance measurements. When we're talking about absorbance measurement, we're interested in how light interacts with matter, and we can characterize the light using its intensity as a measure of how much light there is. For example, if we have some sample in a cuvette, and then we have some incident light coming through at the sample, and the incident light has an intensity of I0, then there will be some light being transmitted through the sample. That is, the light passes through the sample, and it's called transmitted light. And the transmitted light will have a final intensity, say I. Then we can characterize the transmittance T as the ratio of transmitted light versus the original incident light at some particular wavelength, lambda. So T is equal to the final transmitted light divided by the initial incident light. And we can also define the absorbance as the capacity of a substance to absorb light at also that wavelength lambda. And the absorbance is the negative log base 10 of transmittance, or negative log base 10 of I divided by I0. If you think about the mathematics, then the transmittance, because it's final divided by initial, and the final amount of light is always smaller than the initial part of light, then the transmittance is always bounded by 1, so it's less than or equal to 1. For absorbance, because there's a negative sign before the log, then we can write it as the log base 10 of the initial incident light intensity divided by the final transmitted light intensity. And because the initial is always greater than the final, this value is always greater or equal to 1. And because that value is within log base 10, we're looking at how magnitude changes. For example, we usually have absorbance in the range between 0 to about 2 at some large absorbance. If we have too large of absorbance, we might need to dilute our samples so that the absorbance is below 1. What makes absorbance useful is that Beer and Lambert discovered that the absorbance of some solutions varies linearly with the solution concentration and path length, so that the absorbance is equal to the product of extinction coefficient, which is a constant, multiplied by the path length. Say if we have a cuvette, then the length that the light passes through is characterized here as B, usually having a unit of centimeters. Multiply them by the solution concentration, usually have a unit of moles or micromoles. And because absorbance is unitless or dimensionless, then the extinction coefficient will assume its own unit that you can calculate by yourself. Because of this linear relationship, we can construct a calibration curve where we have on the x-axis the concentration of solutions, which we can prepare with known concentrations. Then we can measure the absorbance of those solution concentrations, and they will appear linear. Because we already know the concentrations, then we can measure the absorbance. And this is called a calibration curve. Having this calibration curve will allow us so that if we measure, we have a solution with unknown concentration, we can measure the absorbance of it. Say we have absorbance of here, then we can go on to the calibration curve and calculate what the actual concentration of the unknown solution is. One of the most convenient methods to measure absorbance in the laboratory is to use a microplate reader. The microplate reader will measure the absorbance of each well of a 96 well plate shown here. So we have 200 microliters of samples in each well. So here the colored ones are the samples. that you can put in, but you will also want to have some control wells. For example, this one, it looks blank. It is called a blank control. The blank control should contain the solvent that you're using, and in this case, we are usually using water. So you want to pipette water into some wells so that you have a blank control of the background signal for absorbance. And usually the background signal of the blank control is subtracted from the sample signal. So you have a more accurate measure of the absorbance of each sample without the background. When pipetting the samples, we want to avoid air bubble formation, especially for solutions that have surfactants. So we can use reverse pipetting. In forward pipetting, which is what we usually teach, is that we have two stops for the pipettes. So when we're getting the liquid, we will press to the first stop and then release. So now we have drawn liquid, the liquid in. And for liquid out, we would dispense to the second stop. However, for the reverse pipetting, then it will be different. For reverse pipetting for liquid in, we would go to the second stop and then draw the liquid so that the volume of the liquid is actually more than what we need. But when dispensing, we only dispense to the first stop, and the other part is discarded so that the volume that we're dispensing is what we're dispensing as 200 microliters. This method is usually used to dispense samples that are very viscous or have surfactants that can cause air bubble formation. And finally, be sure to label the wells. Well, usually we have lids for these types of plates, so we can label on the plates that which sample is which so that you don't lose track of the samples. The microplate reader at UW Chemical Engineering is Biotech Synergy H1, and it's located at Benson Hall 121, or the Bindra Innovation Laboratory. Please contact the lab's current supervisor to gain access to the lab and receive training on the equipment. Usually, before using the equipment, we would book usage time on the shared Google Calendar, and be sure to log the time so that you have the equipment access during that time. And before and after using the equipment, be sure to log your usage time on the logbook with your name, access time, and signature. The whole microplate reader setup is pretty simple. We have the main equipment, which is shown here is the microplate reader. And the microplate reader is connected to the computer, and this computer is where you'll receive the data and transport your data to your storage. There are two buttons on the microplate reader. One is the on and off button for the whole plate reader, and one is the in and out button for the microplate holder. So the microplate holder is this rectangle thing, and if you press in to this button, then the microplate holder will open and allow you to place the plate inside. To turn on the reader, press the on and off button for the whole microplate reader so that the plate holder pops up. Then wait for self-diagnosis for the machine. And while you're doing that, you can create an empty Google Sheet for yourself to store the data. Now open the software called Gen 5 3.09. That is the software for the microplate reader. After opening up the software, we want to press New to get a new file. And it will go to measurement mode and leave everything as default. So go to Read. You will have absorbance and everything default. Press yes, and then you want to change the absorbance wavelength to something that you want. For example, for lab 3.1, but it needs a wavelength at 615. For 3.3, we have aggregation of clay. We need 860 nanometers for turbidity. And for bubble fractionation, we're looking at crystal violet at 590 nanometers. Press OK, and then it will want to automatically want to read the plate, but don't let it do it. Cancel it and close the window. We don't want to read the plate yet because we haven't inputted the layout of the plate. If you have correctly labeled your plate, you should be able to identify which well is yours and which well is blank. Now with your plate, go to the software and go to the plate layout settings, and then select blanks and samples and click next. And then samples and blanks, you can change the number of replicates if you need, if it's not one. But usually we can do just one sample. And you can use the clicker to click on the blank samples and the samples by dragging through these wells that you want to measure the absorbance for. Then click OK. Now the software portion is all complete. Now you want to put the plate onto the plate holder. And the plate holder should be extended so that you will put the A1 cell on the upper right so that it fits well on the plate holder. To demonstrate it, first grab your plate, then remove the plate cover. And then place the A1 onto the plate holder top right. Now you're ready to read the plate. On the computer software, click on the plate button, uncheck the Use Lid cell, and then press OK. Now the machine should start reading, and then it will grab your plate and start reading. When you're done, the plate reader will give out your plate, and you can remove the plate from the plate holder. Now you're ready to record your data. Go back from your own sheet to the software for the plate reader. It will ask you to whether or not you want to save a file. Press cancel. And it will ask you want to execute the Excel file. Press yes. And it will generate an Excel report. Select everything from the sheet and then copy it using Control C. And then go back to your sheet and then paste everything using Control V. And then close the file. You don't have to save it. And then go back to the original one and go to statistics. And you will also want to generate the table for this. So generate an Excel file and then copy everything. And then paste it into your own sheet. So here, paste it into stats. So you have everything handy. So here the absorbance value are the blank subtracted absorbance. And you want to use the blank subtracted absorbance for your experiment. And you can close out the software and we're ready to go. To shut down the microplate reader, first close all the program on the computer. Then push the in and out button for the plate holder so that the plate holder retracts. After it retracts, push the on and off button to off state so the instrument is turned off. Now we know how to obtain absorbance measurement using a microplate reader, but why do we need it in the first place? In Lab 3.1, where we're determining the critical micelle concentration, or CMC, using dye titration, we're looking at solutions of different concentrations and measuring their absorbance. At the higher concentration, we have some absorbance, and as we dilute the solution, we see a linear decrease of the absorbance. However, at some critical concentration, we see that the change in absorbance with respect to the change in concentration changes. And when we fit linear lines through them, the intersection of the two linear lines are the critical micelle concentration. And in this case, we do not need a calibration curve, and we're just looking at where the trend changes. And we're specifically looking at the wavelength of 615 for phenolcyanyl chloride. For aggregation of clay, we look at turbidity at 860 nanometers. And in this case, we will need a calibration curve. We will look at the absorbance of solutions with known concentrations. And after establishing a calibration curve, then we can measure absorbance of some unknown solutions concentration and then infer back to look at what concentration it actually is in. Similarly, we can use that for bubble fractionation to look at the concentration of crystal violet at 590 nanometers. In this video, we looked at the theory and practical aspects of making absorbance measurement in microplate reader, and this can be applied to at least 3 labs in the surface and colloid science laboratory.